First of all, let me introduce myself. My name is Saul. I come from the United States, and I do a podcast called NS Brief. Can I see who maybe has heard of that podcast, or a few I know? Awesome! Sweet! Can I take a picture of you guys? Raise your hands there.
Raise your hand.
Sweet! Excellent! Thanks, guys. Awesome. I'm going to put that on the Twitter feeds and websites and stuff. So cool. So I also organize my own local Hogo Hits, so I want to reiterate their message of community service, and you really should, it takes a lot of effort to put events like this on, especially if you're doing it for basically zero pay, and you need everybody's help that you can get to really get the best out of the community. So definitely contribute back when you can. So I want to, oops, that's a red thing. So I'm here to talk to you about core data. Core data is something that I use a lot. How many iOS developers do we have? A lot. Well, I guess about half of you guys. So that's pretty cool. So that's awesome. So I use iOS every day, and I use core data a lot, and I want to talk to you about using it every day. So first of all, let's talk about data. Data is something that is basically at the heart of your app. In Apple terms, we kind of call that the core. So it's really something that is really crucial to your app being actually useful, because a lot of times you're storing stuff. And you want to store stuff that's important to you, and more importantly, what's important to your users. You got a call? Got to answer that? All right. No worries. All right, so data is really important to your apps, and it's really what makes them useful. And the thing about data is it's been around for a long time. Remember in the old days when computers didn't have UIs? Or screens for that matter? Holy crap. All they did was crunch data. That's how important this stuff is. So you really got to treat it with the most respect. So the thing is, nowadays we deal with devices like this. And it's fancy UI and stuff, so that's where we usually start. And the thing is that we'll usually start with the UI, and then we'll eventually move on to data. And that's the natural progression of things, because usually we want to see how these things work. We want to feel the app, and it's not until later that we actually will store the data and figure out all those details. So usually you're going to start off like this, and one thing. Just a second here. I'm going to adjust my notes just for a second. Whoops. There we go. That's easier. Excellent. Go back a slide. So when you're building that, you want to figure out how it works and feels, and yeah. So here, what happens is when you're kind of working with that front end UI that you just built, and you've also got all the data that you figured out that you need to store, and you want to put them together. And what usually happens, you kind of come up with things that the Microsoft people have termed DAOs, data access objects. I don't really like those, because it kind of tells you that there's this boilerplate code, there's this generated code that really you shouldn't be messing with. It's just stuff that the system should be working with. What you really want to worry about is all the domain logic, all the things that are important for your app to actually function and store data. And what happens is that stuff really gets messy. One of the other things that you think about is storing stuff in a database. Now that can lead you to some hairy scenarios too, because what happens is you start to leak all that SQL code into your code, right? SQL is it's another language, and it's useful, it's great. SQL is great for databases, but it's not great for apps. We write apps in Objective-C, and we're focused on object-oriented languages and stuff, so we want to keep our mindset there. And the thing is that what you usually end up doing in a lot of other platforms is you start going this ORM route. And the thing is like, core data is not an ORM. It's an object graph persistence framework. That's a lot of crazy words, but if you think about it, what you're dealing with is objects. And you don't have to deal with actual data or tables and relationships and primary keys and foreign keys and indexes. You really don't need to really think about that all that much. And we usually don't use an ORM when we're doing iOS apps. So that's something to keep in mind. Now, when I was talking about having the separation between kind of this data translation code and kind of your domain logic, it's kind of like this. You've got your core model code, which is kind of all that boilerplate stuff, and then you've got lore over there, which is all the database nastiness, the SQLite code that you got to translate there. So you want to keep these things separate, because when you put them together, it gets really messy. So, core data. Let's talk about core data. I don't know how many newbie people there are in there, but we'll just kind of do a quick overview for those of you who may not be familiar with it. So let's go over some of the objects that are there for you. First of all, we've got the NS Persistent Store. So the NS Persistent Store is where your data lives, and this can be any kind of store really, because you can define your own stores. But by default, iOS and Mac as well, they also give you 4 different types by default. For one, there's a SQLite file, which you're probably more or less familiar with and will probably be using most often. There is the in-memory store, which is great for temporary data and stuff that you really don't care about. There is the XML store, which maybe the Java people might like. There is also the just basically the native store. There's a proprietary format that's binary that Apple has defined for themselves for use with core data. Now you probably will not be using that as much either, just because SQLite is actually really easy to use. And the whole thing is, it doesn't really matter what you use, because I guess it does matter when you're actually trying to push all that data down to disk. But in the interface into your application, it doesn't really matter what is down there. So the NS Persistent Store is generally the layer that is kind of furthest away from where your app code lives. So then you can also, like I said, you can customize this. There are JSON persistent stores. There's a Tokyo Cabinet persistent store out there for all the old school Ruby people who've worked on Tokyo Cabinet in the past. So you can definitely do your own. And there's also, I think Matt Thompson has written an incremental store, which is a newer part of the framework for core data that lets you store stuff in the cloud and lets you do stuff a little more disconnected than you could before. So yeah, that's NS Persistent Store. Hopefully that covers that. Next, we have the coordinator. Now the coordinators, I'm not going to talk about it here so much, because I think when we get later on in the slides, it should be a little bit more evident as to what the Persistent Store coordinator does. But bottom line is that it basically just coordinates all the traffic between a lot of the stuff on the higher layer and all the persistent stores. So the coordinator is kind of a required thing, but we'll get into the details of that a little bit later. The next thing is the NS Manage Object Model. Now, if you work with databases, you're familiar with a schema, especially stuff like maybe a SQL, MySQL, or any kind of relational database. You'll be familiar with the schema, and the NS Manage Object Model is basically your schema. So it's what's really nice about the NS Manage Object Model in the way that Xcode and core data work together is that you have a model editor. So you can define all your objects graphically, all the stuff that, all the software engineering case tools that we had, that might be a weird term for you if you're not too old like me. But if you had, basically it's a nice little object-oriented diagram. You can define entities or objects, and you can define properties, or basically all the instance variables for them. You can define relationships, and you can define subclasses and base classes and stuff like that. So that's really nice that you can do that visually. So, and that's why that's actually why I use core data for every app. And some people will say, maybe you only use core data for this or that scenario. I just use it all the time. Because even if you don't want to store the data, you can just put it in memory, leave all your data there, and just kind of work with stuff, because you've got a really nice way to model all of your business logic in your app. And that's really important to make that part really, really easy. So I highly recommend using core data every day. So put all of your data objects, all your data definition in your app in this managed object model, and you'll be happy that way. So the next object in the stack here is the NS Manage Object Context. Now this is a little hard to describe, but basically the general idea is this is kind of the thing that manages NS Manage objects. And now throwing around a lot of managed terms, but that's kind of what happens here with core data. Core data is managing your objects, so kind of think of it that way. And what we have here is a context, which means that this thing is kind of just it's the way that you interface into the rest of the persistence layer. So you kind of go at it from the top through the context, and you push all of your changes down, and it talks to the coordinator, which knows what the data looks like, because the coordinator knows what the model is. And the coordinator will then give it to the store. Then the store will take care of the actual details of converting all of that data into the persistence format, whether it's JSON or SQLite or whatever. So the context is your interface, and the context will be vending you is how you get new objects and new instances from core data. So this is a very important thing, and the thing to remember from this object here, from the manage object context, these things are really lightweight, these things are efficient, and you don't need to reuse these, and they also can hold on to manage objects. So there's a setting for that, and you can turn that on or off. So that's useful, but the thing to remember is that you want to reuse these a lot, and that comes in really handy when you talk about threading and stuff. So keep that in mind. Don't be afraid to create a lot of these, because it really solves a lot of problems, like honestly, in threading when you use a lot of manage object context. And then the rest of this here, so I kind of consider like this line to be, I would say the lower half of core data. This is where this is where you're not going to really touch it that much. It's only when you get to super advanced stuff in core data that you're really going to touch this. And then the upper layer up here is more of the everyday kind of place to use it. And what happens is, like I was saying, the manage object context just kind of vends a whole bunch of managed objects. And these are all the objects, and they're going to look to your app exactly the way you define them in your schema or your managed object model. So hopefully that kind of gives you a good little overview of kind of the core data and objects and the way they all work together. So let's go over how we use core data. All right. So how do we create our stack? So first of all, let's do this. Let's start with Xcode. Xcode is our friend. Let's not hate it too much. And we'll start here, and we'll pick one of these things. And one of them will have this use core data guide down here. So we check that, and eventually we get stuff like this. Now this is maybe a little bit hard to read, but hopefully not too bad. But we've got our app delegate here, and our context, our model, and our coordinator here. And we know that this is good because Apple said it was okay to put everything in my app delegate. So yeah, that was awesome. So what I also don't like here is that we have save context right here, and we've got the application like this directory. That seems like a bad idea. So yeah, that's not good. All right, so let's go to some more code fail. Well, we've got again save context, and there's a whole bunch of stuff. Right here. I know it's really small for the guys in the back. It's a really magic word. It's awesome. It says abort. You should just love aborting your apps. I mean, your users really love that. You know, that's a 5-star app right there. So otherwise, this is actually not too bad. The lazy loading of stuff, and it actually goes into the persistence coordinator, and that'll lazy load the coordinator and lazy load the manage object model. That's not so bad. It's just the fact that it lives in the app delegate that it's pretty bad. So that's that. Oh, that's a zoomed in version. Sorry. This part was also cool. That the persistence coordinator comes with all these comments. It's like, hey Apple, if you give us all these comments, why don't you just do this yourself and then just template out the code? That would have been better. But I thought this was useful, and it also says abort. Great. Fail. Oh, and it's really helpful. It says unresolved error, and you failed, and then abort. So yeah. Don't use this code. It's not my favorite code down there. So let's see about working with core data. Maybe that's a little bit better. Maybe we'll just kind of leave that stuff alone, and we'll see how do we create an object. Do you see alloc and init in there anywhere? No. It's a little complicated, right? I mean, what are we creating? Can anybody tell? I mean, if you're new to core data, could you tell? I mean, experts should be able to figure this out. I know one dude in the back who knows. Person. Where's person in here? Oh, it's right there, right? It's like so hard. All this crap to make a new person. That's a lot of stuff. That's bad. All right, so that's not good. How about getting data? This is Apple's sample code for fetching data out of the database. And sorry, it's not a database, out of the object graph. All right, what are we fetching here? Well, we're fetching an employee, and then there's some stuff. And we're fetching maybe the last name of this dude who has a particular salary. And we're sorting them all, because I guess we have more than one employee who has that last name, which is okay. Oh, and this is my favorite part. Deal with error. Apple just gave up. Like, just throw in the towel. Baseball. Really? Could have done better, Apple. So, I come to you with a solution, and I call my solution Magical Record. How many of you are using this already? 1, 2... Okay, it needs to be everybody else who's using core data needs to be using this as well. Because, yeah. So this is something that I created way back when I was learning about core data and finding all those fails myself. But basically, it's just an easy way to use it. Core data is actually pretty awesome once you start getting the hang of how the object model works and all the other parts work. It's really good, but it's a shame that their API is terrible. So I fixed that problem, and let's go see some solutions here. So first of all, you remember all that craziness in the apt Elliot? That seems a little bit better. Yeah, you just turn it on. It's a switch. It's a line of code, but it's basically a switch. You just turn it on. I couldn't even fit the application did finish launching method name in the whole thing. I had to shrink it. So this is definitely much better. Oh, you remember this? Oh, yeah, we got this. All right, so let's figure out what actually we were trying to look for in here. So I have a magic button that tells me those are the things that I actually want to look for. And let's bring those up front here, animate something. So let's do something like this. And this, what this does is it puts all the important stuff up front. It basically says, I want all the employees, search for them by this predicate and sort, and all the important stuff that was in all that boilerplate code is now gone. And you can just use one line of code to do whatever, I don't even know, 20 lines of code did before. This also handles errors, and this also will tell you what's wrong. And all kinds of fun stuff like that. And you can specify the context in here. Now, the thing with magical record, that context is required, but I also make that an optional parameter, so you can take that off. And the way that I solve that is something called the default context, which means that magical record, when you turn it on, it will create one for you. So it'll create all of that stuff for you, and it knows where to get it so that it can fill that in for you automatically. But you will need to use the in-context parameter quite often, definitely because sometimes you just want to create temporary stuff, and then you need to throw it away. And if you throw away the context, you throw away all that stuff you just created, which is a feature, and it's really useful. So don't dismiss that just yet. But it's also really helpful in threading. So we'll get to that in a little bit as well. Oh, I had to make this bigger just because I had more room on the screen. Let's see. Oh, so that also leads to more awesome data patterns like this. Like if we had done this before, this would have taken mountains of code with all those lame-ass fetch request things. So now what we can do is we can basically implement data finder patterns on our custom entities. And we can have an employee entity with an employee with ID and specify a particular number and just pass in one of the helpers here. And we can also do the finder create pattern, so we can look. If we don't have it, well, let's give it the value that we do have so that we know we have an object with all the information that we already have. So that's a really easy pattern to create with magical record. And by the way, I can also do this basically automatically. So you don't have to nitpick me there. But this is just a good example of how to use the power of one line of code to do all these handy things that would have taken a long time. And we can also do what I also do is have really nice just helper methods on my domain objects, employee, department, whatever, and I'll have methods that are specific to those objects that relate to all the data that needs to be fetched. And I'll just put them, they have a home. It's basically what it comes down to. They have a home. They're not just all over your app, living in some view controller somewhere, and then you have to create a singleton so you can get access to that method. None of that garbage. Now you've got a home, and notice it's also a class method. I don't know, it might be hard to see with that sign, but it's a class method over there. So yeah, now your code has a home, which is great. So let's talk about threading. Threading is a particularly heinous problem in normal core data, but not with magical record. So now what we can do is that we have this save with block method, and what happens is, when you're dealing with threading, what you usually have to do is set up that context. You have to, first of all, create a new context, and then when you save, you actually have to tell all the other contexts, or any other context that you want to listen, you have to tell them that, hey, this new context is going to save eventually. When it does, go and merge all the changes so that the other context has all those things that you just saved. Now this is important, right? So the scenario where this is important is in UIs. So if you have a UI that's displaying stuff based on data from core data, what happens is if you want to go and change that or process something or compute something, you want to do that on a background thread so you're not locking up your UI. So the thing is, the way to do it is create another context, tell the UI context that your background context is going to save, and when it does, notify. So you're basically listening for an NS notification, and you're basically going to perform a merge There's a merge stuff from context method in there. So you're going to do all this stuff, but this more boilerplate stuff. So that happens, and that's a really important scenario for this. And now what happens is Magic Record has a way to just basically do all that already. So you don't have to worry about it. And the thing is, it's done in a block because this context right here, this local context, is already set up for you. It's done. It's just you just write, basically you write to it and then you save, and then it's done. And then even in this save is already done. You just you just exit out of this block, and the save will happen, and all the error handling will happen, and all the other stuff, all the bubbling up the context chain that's new with iOS 5, I think, all that stuff. That's all done for you. It's all handled. So you can just do all that. Now notice some other important stuff. Remember we talked about transferring context. The contexts are important between threads, right? So the idea here in this slide is that we have an item right here that's in, like, for example, in like the main context or the default context. And what happens when we want to do an operation on it or change it in a background one, we actually need to use this context, which is in our background thread, and then we need to transfer a local copy. And that's why I use a convention that says local item. You can use whatever you name right here, but it's like item and local item, just so I personally in my own code know that they're related. But I transfer it from one context to the next by saying, well, I want the item in this context over here, this local context. I want it in there so that now I can work on it. And now when this save with block exits, it calls the save method on the right objects, and then all the other magic happens. So there's a lot of stuff going on in this little bit of code, but it also gets rid of all the boilerplate that really doesn't really matter. All that matters is you're focusing on the solution to your business problem, which is I have data and I need to save it, right? And you kind of keep focus on that, and you leave all that data persistence craziness to the framework. So the other important part of this thing is the completion block. So whether it's asynchronous or synchronous saves with Magical Record, you can get a completion block. So basically, you know exactly when data is going to be guaranteed to be in your data store, and you can load that up and reload all of your UI that way. This is also another great place to put like a dispatch async to update your table views and all that kind of stuff. Display, update all your UIs, things like that. So that's really handy. And so this is what save with block looks like. And basically, we're just doing a dispatch async on a queue, and we're setting up all of our stuff here. And fun stuff here. It's really simple once you have a whole bunch of other stuff set up. But that's the thing with Magic Record, you don't have to do it anymore. It's already done. So let's talk about some weaknesses. One of the weaknesses that, as I was going through Magic Record and building it up, was logging. And the logging was great, except that you couldn't turn it off really easily. It was a compiler thing. And it was also trying to reuse Cocoa Lumberjack. I don't know if you use Cocoa Lumberjack at all, but it's a really awesome logging framework, which gives you log levels and all kinds of crazy options. You can basically take one log message and dispatch it to different files and stuff like that. It's really cool. If you haven't looked at it, look at Cocoa Lumberjack and use that for your logging. But that was the thing. It was you tried to use that, but it didn't do it very well. So I didn't really do a good job of that. So that was kind of fail number one for me. The other thing is actually this idea of the default context, and that context was a great idea because it's all set up for you and it has a home. The problem is the NSManage object or context part of it. This is a typo. This class part. Basically what I did was I made a class level category on all the core data objects, and that was bad. So that's not good. And the other thing is, and friends. And friends showed up. So that's this guy. This guy showed up. So this was a contribution. So somebody had submitted a pull request to me. It's like, oh hey, we're working in threads. Why don't you just reuse all your context so you don't have to use another one? This is. I mentioned that point earlier. It's okay to create a lot of context. This method will reuse a context on a thread. This was great before GCD. So in a world of GCD, that's basically a thread pooling manager. Your context could be executed, could be accessed and written to on any thread. All you know is that you have a little block of work in those Objective-C blocks, then all you know is that that little block will execute on the same thread, and that's it. If you have, if you have a single queue and you have multiple blocks using this same method that will basically grab the context from that current thread, it will crash eventually. It will be one of those. It runs 99 times, and that one time it crashes. It will be one of those, and it will suck. So this method is going away, and for good reason. It crashes. So this is one of those problems that has been nagging me on the GitHub issues list for a while. The other thing is that Magical Record didn't really support, or it's not the document, it's the managed document. So UI managed document, and also it's Mac corollary NS managed document. They didn't really work very well in Magical Record because they have their own stacks and they have all their own stuff. You could use the finder methods pretty well, but it didn't create your stack for you and set all those objects. So that was kind of a problem for some people. I don't use those myself, but I hear about people and their problems, and as far as that core data goes, and I try to address them as best as I can. Which brings me to Magical Record version 3, new and improved. Excellent. Woo-hoo! Excellent. You're all still awake. You guys need more beer and alcohol. All right. So one of the things that I got early on in Magical Record was, why don't you make this a static library? I'm like, why? I don't know. Why not? So I made a static library. All right. So and that might not be a big deal, but for a lot of people, compiling third-party code into their own code is kind of a problem. So I'm like, well, this also gives me, other than those kind of minor issues, is it gives me a way to release finite versions to everybody. So I can give discrete versions at 3.0 or 3.1 rather than relying on the code. The code will kind of always be in flux, but I can give you solid working versions of the library and more instructions on how to do that, or basically include them in CocoaPods as well. So static library is a minor thing, but it's going to be helpful for us, I think. The other thing is worker or helper methods. So when you're working with core data and you're trying to debug this stuff, it's kind of a pain in the butt because there's a lot of stuff going on. There's a lot of context and objects and whole stack and all that stuff. So what I have in there is a whole bunch of helper methods already there for you. So you can find out, like if you're using the nested context, you can basically print the whole chain and see where, what context you have. And it's just a stupid little thing like that you don't have to do anymore. I also have a way to label your context. So basically there's something called a working name. So if you have a context and it's going and it logs to the console that this one didn't save correctly, if you give all your context a label, you can more easily identify where that save didn't occur. It's super handy. It's just so simple. Just a simple little idea. There's also things with basically migrating persistent stores from one place to the other. Sometimes you want to move them programmatically. I messed that word up. But you'll sometimes you want to move these persistent stores from one place to the other on the file system. And with journaling support, that's actually kind of a pain in the butt because now you have to figure out all the files that are there. Well, I've already taken care of that for you. It's basically a method on NS persistent store. It says move this file or this store to that place and take care of it for you. So there's a lot of that stuff. There's also some migration stuff that we're going to add in there pretty soon. So yeah. I also fixed logging, so that's nice. It has 2 ways to log now. So what I can do is basically I have a debug version of the library where I disable and strip out all the log messages. Big fat compile flag that says this log is going to go away. And so you can just get rid of all the logs that way. Or you can leave them in there, basically in a debug version, and then you can disable or enable them at runtime. So there's 2 ways to do it, and there's 2 settings, and they both matter. One is obviously more important than the other. But there's also just a way that you can do it at runtime, which is great if you're basically distributing an app and you want the logging always off except for when a user submits a certain bug, and then you can turn it on or ask them to turn on or turn on your advanced settings and all that stuff. You can do that all at runtime now, and that's also still managed by Cocoa Lumberjack. So I figured out how to use it. That's basically what it comes down to. So there's that. So the really big idea with Magical Record 3, which should be obvious if in hindsight, I guess, is the idea of stacks. Now, when we talk about core data, we generally will talk about a stack and this mythical stack object, never really existed. Well, I went and made one. So it's a really easy thing to understand if you've used it. If not, it's really simple as well, because it's just something that we talk about all the time anyway. So we had this diagram over here that's basically our general stack with our context, our coordinator, our store, and our model, and all these manage objects that kind of live throughout our app. And so what happens is, this is our stack, all these things down here. So the magical record stack is just a collection of all these things, which is, it's a better home for all these things than our app delegate used to be. And now a stack is also a better home than where it used to be in the old magical record, which, like I said before, was on category methods on the default coordinated classes. So this is a much better home. It's much more custom. It's something more I control. It's not going to go away, and Apple's not going to get angry at me. So the idea of a stack is awesome once you start digging into it, because what you have here is, say we have this stack. I haven't given any details on what goes underneath these stacks, but we have these stacks, and all they're doing is vending these manage object contexts for you. Now this is a useful thing to think about, because what happens is, remember what I said in threading, we need all these contexts all the time, and we need to create new ones and throw them away and just keep allocating these things. The fact that the stack takes care of that for us solves actually a lot of problems later on. We can have one more of these things, because it's super awesome to animate things and make them go away. All right, so we don't have the concept of a default context anymore, but we do have a default stack. And like I said, this is something that I control. I don't see any control over the Apple. We have a default stack. When you turn on Magical Record, you will get a default stack right away. And this is where you want to play. It's nice. The other thing is we have no singletons. Stay away from singletons. They are bad. The default stack is not a singleton. Don't do that. All right. So singletons are bad anyway. That's another whole other talk. I'll get to that later. Maybe after some beer or alcohol or vodka. All stuff, right? Anyway, go through all that. So the other thing is, what we have is, when we work with context, we have a new API here. We have this stack, doesn't matter what it is, and we just ask for a new confinement context. Now I label it as new so that it marks it as something that you need to retain, so it follows the classic memory management rules and also plays a little dark. So I did that on purpose. Don't send me a pull request to say not new. It's there. So there's that. And so remember our setup method. Now it doesn't say setup core data stack. Now I'm a little bit more particular about what these methods are. There's a setup SQLite stack. There's and then we can hold on to this thing, and I think I missed that slide. All right. Anyway, what we can do is this method now returns a stack. It just returns it to you. And you could hold on to this in the app delegate, or you can hold on to it somewhere else. If you have a UI managed document, you can hold on to it there. Wherever you want to put it. You could put it in a property in the app delegate. I'm not going to say not to do that one. That one's actually kind of okay, but probably not. So anyway, there's that. So that's something to keep in mind. You can hold on to these stacks. They are just regular old NS objects, and you can use them. You have access to them. And when we want to save on the default stack, we want to use the stack to do our save with block now. So we have all the same stuff, all the same. It will just use a stack instead of the magical record kind of setup helper object. So keep that in mind as well. But the important thing is the custom stacks. And this is really kind of neat, I think, because when you start putting the object-orientedness together and stuff, it comes out really awesome. So here's just a kind of regular old stack, and what we can do is, there we go. What if we have a stack like this, right, with a whole bunch of persistent stores? This is great for having a whole bunch of discrete files. It's one file, another file, different user files for different users. That's an example that I've actually used with a client. We had, or a different project or something like that, right? So you want to separate all these persistent stores, and this is where you would have. This is where this persistent store coordinator really comes in handy, because when you have this coordinator, it knows knows where all these persistent stores are, and it knows that all the persistent stores store data exactly as described in this model, right? So that's important to know. The other thing is the persistent store coordinator will also take objects from up here, and it will know which store each object goes to. So you don't, when you save an object and you retrieve it from the coordinator, you don't know which store it comes from, but the coordinator knows, and it puts everything in the right place. That's what it's coordinating. And it's really handy because you don't have to write that yourself. So that's awesome. So you can define a custom stack like this in Magical Record 3 and using that stack object. So we also have, let's see, what's the magic one here? Let's see. Oh, so this is also, I think a while ago there was some kind of blog post saying that you could have really kind of true concurrency for saving stuff in core data by having 2 persistent store coordinators and 2 persistent stores, each connected like this. And there's a whole lot of lines in here, but this is another custom configuration that you can have that's totally possible. Let's see, what was the other one here? Whoops, hello, I went too fast. All right, so the other one is, this is a highly simple diagram, this is for the nested manage object context. So you can have multiple of these things, and you can also have a background saving context and all that stuff. And you can just have that in your stack. And the idea is, remember that first thing that kind of vended all these contexts. It doesn't matter what the stack looks like. Because there's an API on a stack that says, give me a new context. The context could come from one store or one coordinator or the other coordinator, or however it's initialized. You don't care. All you care is that you have this workspace that the stack gives to you to work in, and that's all. And that's nice, because then what you can do, you can wholesale replace that stack, at launch or at runtime or whatever options you have. You can say turn on the in-memory store instead of the SQLite store, and you can just totally change what your stack is, and you don't have to change any of your code. It just will figure it all out based on nice, really simple object-oriented design principles. So winding down here, I'm going to just remind everybody that this is open source on GitHub. You can go to magicalrecord.com and you can get there really fast. Project changes. If you've worked with the project, it's been a little haphazard. I am pretty busy and doing a lot of stuff, so I usually get bogged down with the issues and try to, always just trying to keep up. So general support is going to work this way, this far. Always use stackoverflow.com first, and always tag questions with Magical Record. I will get an email every time you use this tag. The thing is, I get that email maybe an hour or 2 after the tag has been used, and there are people trolling Stack Overflow, for lack of a better word, for core data questions to answer to up their rep points. You will likely get an answer faster from them than you will from me, and not because I'm not trying. It's just it will be faster. So we'll do that, and then if we determine that you actually have found a bug in the implementation of Magical Record, then we will open an issue. But we do not want to open issues for general help questions. Leave those for Stack Overflow. It's great, and you get answered faster. So yeah, there's that. And pull requests will always need to be on the develop branch. So we try to use Git flow now, so we have a master develop and we have other branches going on. If you notice that the 3.0 is actually on the release/3.0 branch. So we're trying to use that at least to kind of maintain some sanity. Please submit pull requests on the develop branch. I'm going to probably ask people to do that more often. And if you do submit a pull request not on the develop branch, we're just going to ask you to resubmit. And keep going in that circle until you kind of do things correctly. Unit tests are strongly encouraged. We realize that a lot of people don't test. We want to hopefully present this as an opportunity to learn how to test and learn how to test core data. And it's not, some things are easy, some things are hard. Ask questions definitely about testing. Please at least try to do a unit test. You can fail, it's okay. Because then eventually it'll pass, because that's how the red green factor works. All right, so I want to thank Tony Arnold. If you see him on Twitter, actually if you can get an internet signal in here, that would be awesome. But if you can tweet him and just tell him thank you for helping with Magical Record, because he is awesome. He's been giving up his time and his weekends to help me out because I've been so damn bogged down with all the issues and stuff. But Tony Arnold has been just so awesome and helped me, for one, just collect a whole bunch of thoughts and just help me push things forward. So please thank him on Twitter, if not now, tomorrow, or all of you listening or watching this later. Thank Tony Arnold. So yeah, Magical Record, now 3.0. So hopefully that's a very simple way of using core data. I know it's a very high level overview, it's more of a Magical Record kind of thing, but we can definitely hang around here and ask questions on how to do certain things in Magical Record. But anyhow, you can get a hold of me there and ask me questions there. Thank you.
What are you planning to introduce now after 3.0?
I haven't thought past 3.0. No, the biggest thing that we want to introduce, and so one of the other features that we had was data import. So we want to figure out some way to kind of nice that up a little bit. So there's a whole data import API where we'll just, if you describe your data in your manage object model correctly, we'll just suck in all your data. And that's nice, but we want to kind of make that faster. And we've had some pull requests to make that faster, but that's kind of on my radar to actually get those back in there. The other thing is to actually have better migration support for core data, because core data migrations are such a pain in the butt, and there's so much manual code. And there's so many common scenarios that you just need to write once and everybody can reuse them. Something like progressive migrations or like super manual custom migrations. There's also I've done fully custom migrations where basically I just get the migration manager and just kick it off and everything else is completely custom. And there's some stuff in there that we could kind of use some TLC as far as core data is concerned, but that's generally about as far as I've looked. I've got a lot of other stuff to do. If you have recommendations on what core data needs, I will gladly listen to them and try to note them down so I can think about those later. Any other questions? Yeah. So something about a unique ID and core data doesn't have them? Core data does actually have a unique ID. It's called a manage object ID. And it creates one for every instance. So every time you create a new object, it creates a unique ID for that object. Now that's not something that you can control. And the way that you would do uniquing is basically it's manual. So you're saying you want basically a way to automatically create those unique IDs. It does not, and that's what I'm saying. It's it sounds like a feature request. So if you don't talk to me later, submit it on the issues. That sounds like something that maybe we can look into. But when you do imports also, so doing data import, you do have to have some way to uniquefy the data, or at least determine the uniqueness. So the data import has a way to specify only in the manage object model that a particular field from the source data is unique. So you can tell it the object ID in your JSON data, that field in there is the unique field. So use that to go and look up all and make all your relationship mappings. So the data import does, but the rest of it does not. There's no way to kind of force an object to fail validation on insert when it's not unique. And it's also kind of a hard thing to do though, because if you have threading, think about it in a threading scenario, you have two different objects, right? And you write the same exact data to both of these objects in different threads. Which one wins? It's kind of... Well, which one does win? The first one you created? The second one? The third one? I'm gonna keep going. So what's your real problem then? I didn't hear some of that. Go ahead, can you repeat on that? I know, but before that. Something about working on background context and you can't determine if it's unique? Yeah? Alright, so the way that you handle that, and that's not really a magical record problem, that's more of a maybe not understanding how core data works. The way that you would do that is you would actually create your object, the thing that you're going to sort into, and you'll grab that unique ID. And what you'll do is take that unique ID to every context. You can pass that to any context using asynchronous calls with GCD and stuff. So that unique ID is thread safe. You can reuse that, right? And so what you want to do is take that unique ID and then use basically some of that similar API. You want to ask core data for the object with that ID in that background context. Load up the object, load up all the data that it has so far, and then make your changes and then save it. If you have conflicts, core data will tell you, and then core data will give you some merge options, so you can tell if the store wins or the object wins. You have control over it through core data already. So you don't need all of, you don't necessarily, it really sounds like you just kind of need to change a little bit how you think about the unique ID. And it's not something that you need to look at in rows in particular, it's just these objects are unique. And the other thing to think about is when you create that object, first of all, you want to save it to the data store first, even blank. And then you want that, because you want that record to be there, you want that row in the database to exist. Because you want to take that object ID and pass that around to all your contacts. Because that's the thing that's going to guarantee that you have access to the exact same object in every contact.